Hi everybody, today we're doing a problem about normal distributions. We're going to find middle ranges for both individuals and samples using Minitab and the central limit theorem. Our problem says the daily water consumption of households in a city is normally distributed with a mean of 240 gallons and a standard deviation of 26 gallons. For individual households, what range would you expect to find the middle 60% of water usage? To solve this problem, we go to Minitab, select Graph, then Probability Distribution Plot. We want to view probability. We're using a normal distribution where the mean is 240, the standard deviation is 26. Then on the options, we're using a specified probability. Now you might think we want to pick the middle, but the problem with that is it's asking for two probabilities. So what we want to do instead is say we want to find equal tails. We're going to split up our distribution to where 60% is in the middle, which means we have 40% that is equally distributed in the two tails. So once you click on equal tails, go to the probability and enter 0.40. This shows us each tail has 20%, which means we have 60% in the middle. The water usage is between 218.1 gallons and 261.9 gallons. Now that we have the first part right, let's move to the second part. The second part says, if you were to draw samples of size 49 from the population, in what range would you expect to find the average daily usage for the middle 60% of water usage in the sample? And the first part of the question, we're looking at the range of the middle 60% of water usage. And the second part, we're looking at the average daily water usage. This means we need to use the central limit theorem. For the central limit theorem, we still use 240 as our mean. But instead of using 26 as our standard deviation, we need to use the standard error of the mean, which is 26 over the square root of the sample size. In this case, 26 over the square root of 49. 26 over the square root of 49 gives us 3.7142857114. Let's use 3.714 when we go to Minitab for our standard error of the mean. Back in Minitab, I again select Graph, Probability Distribution Plot, View Probability. And the only thing I have to change is the standard deviation, which we changed to 3.714. Now we have new bounds of 236.9 to 243.1. These bounds of 236.9 to 243.1 are bounds for the average, which explains why these bounds are so much different than the bounds we found in the first part of the problem.